What's up, guys? All right, here we go. Unit 11 notes. We're going to use intermolecular forces to talk about liquid properties. And you guys know this. Like the first one, surface tension. All right, with surface tension, capillary action, viscosity, and vapor pressure. Vapor pressure is by far the most complicated. We're just going to do like a little flyby with it. Surface tension. Well, this is the resistance of liquids to change surface area. You know this. If you've ever done a belly flop or something, it hurts because water wants to stay together. It doesn't want its surface area to get bigger. All right. It's the reason why things, those lizards that run across the water, they can do that because water sticks together so well, it wants to lower its surface area. This is why water droplets are spherical, like they're rounded, they're not square because what it does is it reduces the surface area. All right. And so this is just, it's that. We want to keep surface area to a minimum. Capillary action is kind of wild. This means liquids can be drawn up thin tubes. If you've ever thought about it, like where does photosynthesis happen in trees? Well, it happens at the leaves. Yeah. But the leaves are really high up in the air. And where do trees get their water from? They get them from the roots in the ground. And so that water has to be drawn all the way up the roots, but it doesn't have a heart. So it doesn't have a muscle pushing that fluid anywhere. And so what they use is this capillary action. And in a small tube, liquids will get drawn up these small tubes. All right. Now, you'll have two different shapes of meniscuses. For water, you got that one going down. It's because water is a little bit attracted to glass. We know that because it sort of sticks to it. Whereas something like mercury is repelled by glass, so you get this oppositely shaped um, meniscus. All right, because water is attracted by glass, mercury is repelled. Viscosity, this is the resistance of a liquid to flow, which means if it has a high viscosity, it flows really slow. So think about like honey versus water. All right. Honey is going to have a much higher viscosity. It's going to flow a lot slower. All right. Now, this viscosity can change with temperature. Like you guys know this, if you put maple syrup in the fridge for whatever reason, um, if it's in the fridge and cold, it flows really slow. But then as you warm it up, it starts to flow faster. Now, vapor pressure, this is actually super important. Um, what this is if you have a bowl of water or any liquid, some of those particles need to be in the gas phase above that liquid, and there's a threshold pressure. All right, there's a threshold that has to be there. This is why things evaporate. A question that I would ask you guys in class is what's the difference between evaporation and boiling? Both of them, you have a change from a liquid to gas, but evaporation works because of this vapor pressure. So a certain amount of liquid needs to be a gas right above it, except gas is spread out. We know this. So a little bit of that liquid turns into a gas and then spreads out through the room. So more of that liquid has to vaporize in order to have gas above the liquid. It's measured as a pressure, not because that's how we measure gases. And vapor pressure increases with temperature. All right. So if your vapor pressure is 100 millimeters per mercury at room temperature, at 75 degrees Celsius, it might be 200 millimeters of mercury. And so you have an increase with temperature. Now, when something boils, the reason that it boils is because you've heated it up high enough that the vapor pressure, there's enough particles above the liquid, that pressure equals air pressure. And this is one of the reasons why when you're in like Denver or at very, very high altitudes, water actually boils at a lower temperature because there's less air around. And so it doesn't have to be hot enough to equal air pressure. So these are properties of liquids. You should know vapor pressure is something to think about. Also, because things are evaporate, as you move gas particles away, more of that liquid has to evaporate. It's why when are you colder getting out of water? On a slightly warm day where it's really windy, or maybe when it's just a little bit cooler but perfectly still? Usually that wind is going to cool you down quite a bit because it's blowing these gas particles away. And as these gas particles blow away, more water evaporates and it sucks energy from your body, cooling you down. It's the reason that sweat works. And sweating is actually a really, really important biological function.